Hello, guys. I'm very happy today because of the topic we are to treat, the Lupita's principle. Remember, it's what I promised last time on our last topic. That is the topic we treated lastly. And today I am to fulfill my promise by putting down or bringing to your understanding what the Lupita's principle is all about and how we can apply it to actually solve questions under limits by evaluating them. Okay, before we go into our topic properly, I would like you to please subscribe. Subscribe to my channel. Like if you like the video, and don't forget to hit the notification button so that whenever I release new videos of such, you will not mix it, or you will be the first to be notified. That's the reason for the notification bell. So don't forget to hit it up so that whenever I release a new video, you shall be notified. Okay, guys, without wasting time, God bless you as you do so. Our topic today, like we're saying, is the Lupita's principle. What does this principle state? It states that if we have two functions, f of x and g of x, like it says here, this principle states that if the limit as x tends to a of two functions, f of x and g of x, equal to 0 at the numerator and 0 at the denominator, then that function is indeterminate, or it has an indeterminate value. Let me explain what I am saying again, or what this principle states again. This principle says if after we have substitute a in x wherever because from our last class we explained this. When we have let me do that on the rough sheet so that we can quickly, just to brief you people up on what happened last class, for those who are visiting my channel for the first time, before we can continue. Last time what we thought was, if excuse me, okay, if we have a limit as x tends to, let's say, 2 of 2x plus 4, what this means is wherever we have x in the function f of x or g of x, if you consider this to be g of x, then say g of x. If you consider it to be f of x, then say f of x. Wherever we have x in this function f of x, we simply substitute it by 2. Oh, you're not seeing. Sorry for that. What I was saying is, last class, what we thought or what we learned was, when we are given a limit, the function, because last class what we thought was the limit of a function. When we're evaluating the limit of a function, and it is whereby we are giving it like this, then what is expected of us is, wherever we have x in this function, we substitute it by 2 and simplify and evaluate. Okay, now what will be the answer here? We'll simply have 2 into 2 plus 4, which is equal to 8. That is our answer here. Okay, now here the Lupita principle says, if after you substituted a in g of x and f of x, and you have 0 at the numerator and 0 at the denominator, then this this limit or this function will be called, and will have an indeterminate value. And it is not allowed in mathematics. It is not permitted in mathematics. So once you have this, you write there an indeterminate value, but you use the L'Hopital's principle to solve in this case. How will you use the L'Hopital principle? That's what they say. If it gives you 0, if it gives you this, then it is called an indeterminate value. And to evaluate such a limit, what do? We apply the following steps. Okay, any of the following. We apply any of this where necessary. What is the first thing to do? We apply any. Put here any. It is not all that are applied in all equations. So you will always see the need to apply any of these in different equations that will be given to you. Okay. I would quickly like to, what is the first step? It says factorize if necessary. The second one says rationalize if necessary. Differentiate g of x and f of x and g of x independently. That is the numerator and the denominator separately. That's what it means, independently. Okay, now we proceed. We'll take some examples. Example. If we have let me quickly look at an example in a book. If you have, okay, I've gotten one. Let's say it says evaluate the following. And it gives us 1. Limit as x tends to 4 of what? Of x squared minus 16 all over x minus 4. This is our first example. This is 4. This is our first example. The second example, let me just put them also, that will just be solving and going. The second example says evaluate limit as x tends to 1. This is 1. 1 of x squared minus 1 all over the root of x minus 1. Root x minus 1. Okay, that is it. These are our 2 examples. We shall solve this, and I think it will be enough. It will break out all this. It will bring out all of these steps. We will use all these steps to. Okay, we'll write solution. When you put your solution down, hope you can see. Okay. Once you write your solution, number 1, limit as x approaches 4 or tends to 4 of x squared minus 16 all over x minus 4. Watch this keenly. Then ask yourself the question. Is the Lupita principle necessary here? What is the condition for the Lupita principle to be necessary? The Lupita principle, for it to be necessary in the evaluation of this equation, the numerator and the denominator must be 0, so that we have an indeterminate value. Then let's check to see whether it is the case. If we input 4, we have 4 squared minus 16 all over 4 minus 4, which is equal to 0 on 0. You see that it gives it, the condition permits us to apply the Lupita's principle. Okay, having proven that, we write indeterminate value. It's not allowed in mathematics. I always like your examiner knows this. Okay. We proceed now by applying our first step. After all, is our first step applied here, necessary here? Because we apply it if it is necessary. It doesn't mean you must apply it, because in some cases you will not need to factorize. Maybe you just need to rationalize. Maybe you just need to differentiate directly. Okay, so is it necessary that we factorize this? Yes. I am seeing here x squared minus 16, and I'm seeing at the numerator, at the denominator, the same thing. And I'm seeing that if I open this, I'll have something similar to this. Can you see it? I am seeing that if I open this, I'll have something similar to this that might cancel up and make my work less bulky. So let's proceed. We have here limit as x tends to 4 of x minus 4 into x plus 4, difference of 2 square, all over x minus 4. You see that what I was saying is coming true. This can go with this, so that we will be left with limit as x tends to 4 of x plus 4, which will simply give us 4 plus 4, which is equal to 8. As simple as that, guys. You see how it's coming out. Okay, let's take our second example. Our second example says, here is our second example. I will just recopy it first. Limit as x tends to 1. Our second example says 2. Limit as x tends to 1 of x squared minus 1 all over root x minus 1. That is our second example. Hope I've written it well. Yeah, everything is right. Okay, how do we solve this? Like in this second example, you can watch. It look a little bit more complicated because we shall not be applying only one step here. Because I can see in the numerator, we might be factorizing, but factorization in the denominator might not be possible. Are you seeing it with me? So what are we to do here? We shall allow ourselves to flow in the direction of the equation. So how do we do that? We say this is equal to, I will factorize the numerator, x squared minus 1, x minus 1, cancel this square, into x plus 1. Difference of two square, remember, all over. Also, remember that x root of anything is the same as that thing to the power a half. That is indices. Root of x is the same as x to the power a half minus 1 minus 1. We will have again here limit as x tends to 1 of if you open up all of this, we shall have, hope you can do that. You can open all of this. I won't like or should I open it in a rough sheet? Let me just open it in a rough sheet. I don't want to make my work bulky and very nasty. So if we open that, we'll have x squared plus x minus x. You see that this and this will cancel, minus 1. I could just have written here x squared minus 1. But for benefit of doubt, let me just open it like this. So that is what will happen here. So that we'll have x minus 1 that I'm going to write down here. So we have x squared minus 1 all over, what are we having there? X to the power a half minus 1. That's what we have to have there. This is x to the power a half. Okay, this is the same as, you see that from here, there is nothing you will do again that concerns factorization. What we need to do here is, actually, even we have come back to this. Which simply means it was not even necessary to go through this. You are seeing the thing. So it would have been better if we just differentiated at once. You see that it is the third step, because it says factorize if necessary. You see that here factorization wasn't necessary. To factorize here, it was not necessary. So hope as you are seeing, rationalization can also go. Yes, should we continue with rationalization or factorization? Since we have already raised this to the power a half, I would like us to differentiate. But after we've differentiated, we'll use method 2 to rationalize the same question. We'll consider rationalizing and call it method 2. So let's proceed the way we are proceeding. If we are to differentiate this, I want just to point something on differentiation. What is applied when we are differentiating something like this? When we are differentiating something like this, it states that because the principle says differentiate. Normally, we should have been talking of I think quotient rule to differentiate this under differentiation. But the Lupita principle says differentiate g of x and x of x and f of x independently. It means you differentiate the numerator and the denominator separately. So to do that, we'll differentiate the numerator. How? How do we do this? We say if we are to differentiate something like x to the power n, if you are asked to differentiate this, how do you differentiate it? We say we multiply x by its power and subtract 1 to that power. That is the differential of this, called f prime. F prime of x. F prime of x is equal to this. It means if 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 f of x is equal to n, x to the power n, f prime of x is equal to n x to the power n minus 1. That is the principle we are applying here. Okay, this is a formula. If you haven't understood, in some videos that will be coming later, I will explain this better. So we are going to apply that principle right here. How do I apply this? You see that we have here. Also note that in differentiation, anytime you differentiate a constant, you always have 0, because we're having constants here. Okay, we have here 2x all over, because if we differentiate 1, we have 0. That's why we don't need to apply 1 again. Okay, all over, we have here half x to the power. Okay, another thing. If we subtract 1 from half, what shall we be having? We shall be having negative a half. Hope you will not ask me how. If you doubt it, let us prove it. Remember what we are doing. We multiply x by its power, this, and then subtract 1 from the power. Normally I would have just put a half minus 1, but I want to do it on a rough sheet so that our work will be presentable. I want to prove this. I want to show you how I've gotten this so that you will not be confused. Okay, here we have a half minus 1. That's what we're supposed to have. How do I solve this to have minus half? We'll look for the LCM. Our LCM is 2. 2 into 2 is 1. 2 into 1 is 2 times 1 is 2. Our minus sign go there. Okay, you see that 1 minus 2 is minus 1. So we'll have here negative a half. That's how we need to have this. So we can proceed. Okay, I hope you understood that. Let's put this away. Okay, how do we proceed from here? We substitute 1. So now we have limit as x tends to 1 of this is 1 of 2 into 1 all over half into 1 to the power negative a half. You see that if you evaluate all of this, you shall simply have a half. You shall simply have a half there. Use your calculator if you can't do it mentally. We have here 2 all over a half. And if we'll swim this up, what will it give us? It will give us 2 times 2, which is equal to 4. That's our answer. Hope you understand what I did there. What I did here was, I did this. This is 2. I'm a man, I might make errors, so don't 2 times, I'll swim everything up since the sign here changed, all over 1. 2 times 2 is 4. That's what happened there. Okay, remember I said I will use rationalization on this same question so that it will be that we have touched all the three steps. We won't leave anyone aside. We've used factorization, we've used differentiation, which is this one. Now we have to use rationalization. Let's call this method 2 for the same question. Method 2. The question is limit as x tends to 1 of x squared minus 1 all over root x minus 1. That's what our question is. Okay. If we were to rationalize this, how shall we do it? You see that we'll be talking of conjugate since we have a set under. Okay. What is the set of this? We have here x squared minus 1 times root x plus 1. This is the conjugate. All over x minus 1 into root x plus 1. Under set, when we'll be treating set in our videos to come, we'll explain this. This is under set. Okay. And what we are multiplying the numerator and the denominator by is called the conjugate. So, from here, if you simplify all of this, you simply have x. Let's do it. Let's not shortcut. Let's not use a shortcut so that it will be understood better. If we open this, we'll have x minus 1 into x plus 1 times root x plus 1. All this all over. I want us to open this. Maybe let's do it on a rough sheet so that our work will look presentable. Let's use our rough paper. Let me use another one. Let's use this. Hope you can see. Okay. Let's open this here. I want our work to be presentable. Root x minus 1 into root x plus 1. If we open this, what shall we be having? We have x. When a set multiplies a set, when a root multiplies a root with the same thing inside, it always cancels. So don't ask me how I got x, because I multiplied this and this to have x. This and this, you will have plus root x. This and this will have minus root x. You see that this and this cancel. And this will have minus 1. So we'll simply, from all of this, we'll have x minus 1. That's what I wanted to explain, that if we open all of this, we'll just have x minus 1. So that is how we'll get x minus 1 down here. Let's keep this aside. Hope this is understood. Okay, let's proceed. You will see here that this can take away this, so that we'll just be left with limit as x approaches 1 of x plus 1 into root x plus 1. You see here that we shall be having 1 plus 1 into 1 plus 1, since root 1 is 1. Or do you want me to put root 1 here? Let me just put it there. Okay. What will be the answer? It will be 2 into 2, which is equal to 4. Do you see that they are the same answers? See that this is equal to this. Different methods. The same answer. Okay, guys. If you have watched right up to this level, why not subscribe? Subscribe to my channel. Like the video. Share. Comment. So that I will know your weak points and which videos you want me to upload most often. Thank you guys for watching. Thank you for liking and subscribing. See you next time on our next video. Don't miss the next video, for it to bring lot more. Thank you for watching. Bye bye.